AI can write functions in seconds. Ask it to generate some code for you, and it will generate it much faster than humans can. And as software engineers, this can feel a little scary, especially when we see how fast AI is growing, how fast it's improving, and how it's getting better and better at the tasks that we do every single day. But while everyone's debating whether AI will take our jobs or not, I want to focus on something different. I want to focus on the skills that AI can't replace, the things that we can do to survive in this world as AI becomes more and more prevalent. Because yes, AI is getting great at writing code, especially boilerplate code, and it's great for things like documentation, research, data analysis, and different repetitive tasks that take up or used to take up a lot of our time. But there are still a lot of skills that AI can't do and AI can't replace, skills that are uniquely human. The reality is AI isn't going to take all developer jobs, it's just going to change how we work. And the more prevalent AI becomes, I think the more companies will rely on us for those other skills, for those skills that AI can't replace. They will become even more valuable. Even in the most AI automated scenarios, you still need people making decisions. You still need people to decide what to build, people to ensure quality and standards, people to handle management and professional working relationships. All of these things are not going to disappear. So today I want to talk about the specific skills that I believe will become even more valuable as AI becomes a bigger part of our work. These are the skills that companies will look for and the skills that will make you future-proof. So let's look at each of these skills in detail and let's look at why AI can't replace them and even more importantly, how you can build on them. Hey, I'm Becca. Welcome back to my channel. If you're new here, I'm a full-time software engineer, part-time Pilates instructor, and someone with multiple different interests and multiple different passions. I love sharing bits of my life, insights into my career, tips on productivity, and everything in between. If you enjoy this content, please don't forget to subscribe so you don't miss future videos. But let's get straight into the video. So the first of these skills is systems thinking and architectural decisions. So systems thinking is about seeing the bigger picture. It's about thinking about how your application, your infrastructure, and your business requirements all connect together. And architectural decisions are about having that high-level overview of how to structure your code, your data, your services that will impact your project. It's about thinking about the overall structure and the relationships and interactions between the different components. And why does AI struggle with this? So AI finds this hard to do because it's very good at writing individual functions, but designing scalable systems requires understanding business context, trade-offs, and long-term implications. AI doesn't know your team's constraints, your company budgets, your company growth plans, and it can't weigh trade-offs between performance, maintainability, and development based on your specific context. As an example, if you tell AI what you want your code to do, I'm sure it could write that for you, but it might not know where exactly to place this code or how to optimize it or what the best architectural decision is for that specific context. For example, should it be a new microservice? Should it be within one of the existing services? Should it be a serverless function? All of these decisions will be impacted by the existing context that it lives in. So how can you actively develop this skill? I think you need to start by understanding system design and architecture by reading into these topics. Learn about different design patterns and architectural decisions. There are so many books out there. And in your company, in places you've worked, have a look at the decisions that have already been made and try and figure out why they were made that way, and maybe are there other patterns or other ways of doing things that you think would suit it better. For example, me personally, I'm trying to learn a lot more about architecture at the moment, and I'm trying to use that within my role at work. I'm trying to have more of a say in these decisions at work and just get more involved in that side of things. So the next skill is debugging, and in particular, being able to debug in complex and multi-system issues. So debugging is the process of finding and fixing errors or bugs in different software systems. It involves identifying the root cause of the issue, isolating it, and then fixing it. It gets tricky when something breaks and the problem isn't obvious, when the problem spans multiple different services or external APIs or databases, or when there are loads of systems involved and it's quite hard to find that root cause. It can mean tracing issues across entire systems, and the root cause of the issue might not be where the symptoms show up. So why does AI struggle with this? AI can help you debug an isolated issue, but it can't take into account all of the different factors coming in from everywhere and everything that's connected, like your different logs, your databases, what is calling your endpoint, what external endpoints are you calling, and all these external systems that it doesn't have access to. It doesn't understand your infrastructure or how data flows through your application or which databases it's reading from or sending data to. So for this skill, I think it's a great idea to actively work on your debugging skills. Learn different observability tools, how to set up better logging, and build your systematic investigation process. For example, maybe having a mental checklist, knowing what to check and where to spot issues in different cases. And obviously a lot of this will be unexpected, and there's kind of no general rulebook or guide to follow in all of these different cases. But the more you build up that experience, the easier that you'll find to debug in the future. The next skill is communication. Now, communication is a massive topic, and there are so many different elements and aspects to communication, but I think it will become a really, really valuable and even more valuable skill for software engineers as AI starts to become more prevalent in this industry. So communication can involve technical communication, can involve cross-functional communication, stakeholder communication, and also requirement translation. I think a massive part of it will become bridging the gap between technical and non-technical worlds. So what business people want and what can technically be built. It's about translating vague business requirements into solutions that can actually be built, about explaining technical decisions into language that everyone can understand, and leading discussions where technical and business priorities clash, helping junior developers understand reasons behind technical decisions, and helping communicate to people higher up and managers and people of every different skill level. So this is something that I think AI definitely can't compete with. Humans love to communicate with other humans, and that will never disappear. AI can't navigate competing priorities or manage expectations or navigate human dynamics in a room where the CTO, the engineers, and the product managers all have completely different priorities. But that's where the human aspect comes in, because we can do those things. We can learn to work with those who have different priorities and different ways of working and different skill sets. It's about building trust with those colleagues and with the different teams that you're part of and with those different people that you interact with. It's about building up those relationships with the stakeholders and with people across different sectors and different disciplines and different areas of your work. As an example, understanding the different nuances of client requirements or different priorities is essential for this. AI can build a solution for you, but it can also easily misunderstand requirements. The solution it comes up with may be a solution, but it may not be the best suited solution. And that's where these back and forth conversations become so valuable. As another example, you have to be able to explain to stakeholders why things take as long as they do or what the kind of timeline will be. And that will depend on things that AI won't know about, such as your backlog or your technical debt or other priorities that the business has going on. So in order to develop these skills, it's a good idea to practice communicating with a wide range of people. So not just your direct team and other software engineers, but also communicating with different stakeholders, different product managers, and non-technical people as well as technical people. When you learn new concepts, maybe try and explain those concepts to non-technical people in a way and in language that other people can understand. Or maybe things like translating ideas between back-end people and front-end people. Thinking about types of people that work very differently from each other and thinking about how you can bridge that gap between those two separate worlds. Next is creative problem solving. Creative problem solving is about finding novel solutions when the obvious approaches don't work. It's about combining ideas from different domains and thinking outside conventional patterns and approaching technical challenges from unexpected angles. Now, AI struggles with this because AI is built on existing patterns. It excels at pattern matching and recombining known approaches. But truly creative solutions often come from connecting dots that have never been connected before, or applying insights from completely unrelated fields. So those people with a genuine curiosity in multiple different things are likely to excel here. Now, there are a few ways that you can work on your creative problem solving skills. Firstly, I would always encourage people to have multiple different interests or at least one different skill or interest outside of your main career. Now, these things bring a variety into your life and they'll allow you to meet so many different people that you might not have met otherwise and wouldn't have met through work. This will then lead you to conversations that you wouldn't otherwise have, and it will allow you to see things from a different perspective. Learning new skills also works different parts of your brain that you're not used to working, and it will help you see the world in a whole different way. And then there are some exercises that you could focus on to specifically work on this skill. So, for example, there's something called the Bad Ideas Brainstorm, and this is where you literally just brainstorm bad ideas. So thinking of the worst possible solutions to a problem. And what this does is it removes any of that pressure and any of that expectation that comes with trying to find the best solution to things. This loosens up your thinking and it can often lead to some really great solutions. Another approach to working on your creative problem solving skills kind of links back to the communication point, and it's about being able to explain concepts or technical concepts to non-technical people. So often you'll find that those people might think about things a lot differently to the way you might think about things. Their brain might work in a completely different way, and you'll have to find new ways of explaining things each time, depending on who you're talking to. And often the questions that they ask can help you see a different perspective of the problem as well. It might open up gaps in your thinking, or it might open up little blind spots that you didn't realize you had. Their questions might expose some assumptions that you had made that you didn't realize you'd made about a certain problem or a certain situation. And it might actually help you understand the problem better. Now, the next thing is around ethical decision making and security. So this is about making the right judgment calls, about the right thing to do when it comes to building technology that affects real people. It's about making different technical decisions while also thinking about user privacy and security risks against usability and business goals against potential harm. It includes different decisions around data collection, accessibility, security trade-offs, understanding how systems can be exploited, and this principle of just because we can, it doesn't mean we should. Now, AI can implement security features and discover different vulnerabilities in the code. What it can't do, though, is understand different ethical implications and how things impact the real world. It doesn't understand the trade-offs between security and usability. It can't understand the cultural context or make judgment calls about what's right in complex situations. When you're deciding whether to implement a feature that could be used for surveillance, or you're deciding how much data is too much to collect, or how much data retention you're able to do, AI can't navigate that moral complexity. In terms of real world examples, we will always need humans to overlook that area of security and ethical implications. And it becomes more complicated when you have those legal aspects involved as well. We will need people to adapt to changing regulations in AI, in GDPR, and in different industry compliance. In terms of developing these skills, I think a great starting point is just that awareness of all of these issues and reading about all of these things in the news and how they've affected different companies, how they've affected the law, and also the real world application, what it means for the general public. Thinking about the privacy concerns and flaws in things such as maybe facial recognition or other legal aspects. And for security, I think it's really great if you can relate this to your everyday work. So thinking about, are your endpoints secure? Are there any vulnerabilities in the code? And what you can do to make things in the code more secure. So things such as SQL injection, or thinking about authorization and authentication, and thinking about things such as should sensitive data be logged or not, or should internal logic be sent up to external sources. All of those things like that you can think of in your day-to-day work and how to make things more secure. This is also where collaboration with security teams can be very beneficial, and that also links back to the communication side of things and collaborating with different teams and with different people. AI can feel very overwhelming sometimes, especially as software engineers. But instead of worrying about what AI might do, focus instead on what you can control right now and how you can develop these uniquely human skills that I think will become even more valuable. Thank you so much for watching this video. If you enjoyed, please don't forget to like and subscribe, and let me know in the comments if you think there are any other skills that I've missed off the list. Hopefully see you next time.